Let's understand autocorrelation function, also called as ACF, and partial autocorrelation function, PACF, in this one very clearly. We will understand the importance of it, why it matters, and also the math behind it very clearly. Right? Now, say you have a time series, you have the date and your value. This data forms your time series, right? In many of the time series that you will see in the real world, you will find that the previous values of the same series can be helpful to predict its future values. So suppose if this is D1, D2, if these are the days or the time points in your series, and the values I will write as 1, 2, 3, 4, and 5. For the sake of simplicity, I will write like this. And we also have the lags of the series, lag 1, lag 2 of y, and so on. We're computing the lags also parallelly. So this will be hash. So this is 1, 2, 3, and so on. You have the series and its lags. Now, what I'm saying is, if you want to predict or model this series based on its lag, you will write the equation something like this. So y is dependent on its lags itself, lag 1 of y, lag 2 of y, and so on. As many lags as you want. We don't know how many lags it is dependent on. We will not fill this up, but this is an idea, right? The current value of y is explained by its past values. So to predict what this value will be, we know the value of the lag at this point. This will be 5. Lag 1 of y at d6. This is unknown, but lag 1 is known. Likewise, lag 2 also is known. This is also known. We want to know what this value is, right? So that's why this is useful, because we will know the actual values of the lags. And this is the concept behind autoregressive models. So because we are predicting y as a function of itself, its own lags, it is called autoregressive models, simply called AR models. Right? This is the concept behind these models. Now we want to understand what is the strength of this relationship between y and its lags. And in addition to this strength, we also want to know how many of these lags have a statistically significant relationship. To understand this, ACF and PACF will help you. First, let's see ACF. So what does ACF mean? ACF is nothing but the correlation of y with its own lags. That is y and lag 1 of y and lag 2 of y, and so on. The correlation of y and its own lags is nothing but ACF. That's all there is to it. Now, whenever you are going to compute the ACF using a statistical package, be it R programming language or be it Python stat models, whatever you are using, whenever you are computing your ACF function, it will throw out a resulting graph that looks like this. That looks something like this. You might have seen this somewhere. It need not be the same pattern all the time, but something like this. Something like this type of a chart you would have seen. Here, this varies from 1 and -1, and the y-axis here is nothing but the correlation of y with its own lags. So this is lag 0, this is y itself. If the first data point is at it's coming till 1, it will be lag 0, lag 1, lag 2, lag 3, 4, and so on, right? Like this you would have seen. This is nothing but the ACF plot. The correlation of y with its own lags is nothing but the ACF plot. In addition to this, you will also see a significance line, something like this. The significance line on both sides of the plot. What this means is, whichever lags are crossing this line, it means that many lags are having a statistically significant relationship with y. So here in this case, up to 3 lags are crossing this line, right? Up to 3 lags are crossing. So up to lag 3 is having a statistically significant relationship. That's what ACF means, and that's how you interpret this chart. Now let's understand what does PACF mean. In PACF also you will see a very similar chart, but typically the PACF chart will fall much faster. First PACF will be like this, second will be like this, third will be like this. It will fall much faster compared to the ACF plot. Not always, but generally that is the trend, right? Now what is PACF and how it is different? PACF also conveys a very similar information to what ACF conveys. it also tells you what is the strength of the relationship between the lags of y and itself. But what it also tells you additionally is it tells you the strength after removing the, suppose this is lag 3, suppose this is lag 3, lag 2, lag 1. If it tells the strength between lag 3 of y and y after removing the effects of the intermediate lags, after removing these two lags, effects of these two lags, it is telling the strength of the contribution from lag 3 alone. That's what PACF tells, right? This is a more pure filtered version of ACF. Now, mathematically, what it means, what internally happens to compute this number is, this is PACF. What internally happens to compute it is your y is modeled as a linear regression model of its own lags. Y as a function of y1, y lag 1 plus y lag 2 plus y lag 3 plus lag 4 and so on. Suppose if you want to find the autocorrelation, partial autocorrelation value of lag 4, right? You will fit this model. Then after fitting this model, you will get a beta coefficient for each of these variables, right? So alpha plus beta 1 y1 plus beta 2 y2 plus beta 3 y3 plus beta 4 y4. This is the coefficient of y4, right? That nothing but this coefficient is nothing but the PACF, partial autocorrelation function value for that particular lag. Now, can you tell me what will be the partial autocorrelation function value for lag 2? You would say, you will be tempted to say it is B2. It's not B2 because you need to explicitly form a new equation to compute PACF of lag 2. You need to form an equation something like this: ln of y1, y lag 1 and y lag 2 alone, right? You need to form a new equation. After forming this equation will give you the alpha and beta values. This is not the same values as what you see in this equation because you would have only two terms here. So beta 1 y1 plus beta 2 y2, right? This value is the partial autocorrelation function for y2. This beta is not the same as this beta 2. This beta 2 and this beta 2 are not the same because the equation itself is different, right? So that's the concept behind ACF and PACF, and both of these are used traditionally to do AR, autoregressive and moving average time series models.